A very good morning. I bid to Dr. Mohammad ZULFAHMI bin Bahaudin, lecturer of General Physics course, code SCES 3193. I am Darvin Eaganathan from 1 PISMP RBTY. Moving from recognizing to understanding speech is the next major frontier for speech technology. Zhudong Huang's notable and inspirational quote delineates the immense growth of speech recognition technology in the current era of everlasting and ever-evolving modernization. Based on the quote, today I will be presenting and discussing about speech recognition, a complete perspective. Within this presentation, we will be taking a trip through these contents. For instance, I'll be discussing thoroughly about introduction, background problem, problem statement, research question, research objective, literature review, chronology of advancement in speech recognition, research methodology, analysis and result, conclusion, and references. First and foremost, introduction. Speech recognition, or also known as automatic speech recognition, is the process of converting speech signal to a sequence of words by means of an algorithm implemented as a computer program. Speech processing is one of the major fields of signal processing. Speech recognition area aims to develop techniques for speech input into a machine. The early computer systems were limited in scope and power, but the revolution in computer technology has evolved the field of automatic speech recognition. Nowadays, it is easy to store huge database for speech recognition due to advancement in computer technology. There are only few languages on which speech recognition systems have been developed where there are a lot of scopes to be built speech recognizer in native languages. Advancement in statistical modeling of speech has gained a widespread of application in the field of speech recognition. Moving on is the background problem. Speech recognition has been functional, convenient, and beneficial in the daily life of each and every person from every nook and corner of the world. Nevertheless, with the enormous momentum of rapid growth, there were challenges of speech recognition which have been dealt with. For instance, speech recognition software is not always able to interpret spoken words correctly. This is due to computers not being on par with humans in understanding the contextual relation of words and sentences, causing misinterpretations of what the speaker meant to say or achieve. Besides, voice recording machines detect sound waves that are generated through speech. Background noises in rooms make it hard for systems to understand and distinguish between the specific sound waves from the host voice. This blurs the sound picked by the devices, confusing and limiting its processing ability. In addition, accuracy levels of voice detection have high error rates. Machines still have about 8 to 12% of errors, which more than twice as much as humans make in their day-to-day speech. Errors in encoding of collected data are crucial to performance, as it is the first step for the voice recording devices to act upon. Moreover, echoes leads to a disorganized returns of sound waves back to the receptors, as they are basically sound waves reflected across various surfaces like walls and tables. Thus, this reduces clarity in speech recognition. Next is the problem statement. The last 5 to 10 years in automatic speech recognition, ASR, have been mainly focused on minimizing mistakes while decoding voice inputs. Yet, speech recognition software, like any other products, has limitations. With the help of the right type of service, it is possible to reap the benefits that this software offers while also ensuring textual accuracy. Thus, new innovations and revolutions in speech recognition that are being studied, considered, and released are used to address these issues. Now, let's take a look at the research questions. The research questions are, what is the differences between the older and modern speech recognition technology? How to know performance evolution of speech recognition system? Is the speech recognition technology developed suitable and convenient for the users? Is there any additional challenges in the applications of speech recognition technologies? These questions will be answered in the upcoming discussion. The following is research objective. One of them is to identify the differences between the older and modern speech recognition technology, to identify performance evolution of speech recognition system, and last but not the least, to identify the benefits and challenges of modern speech recognition technology. Moving on is literature review. Speech recognition system. The speech sound is captured using a microphone to convert it into electrical signal. The purpose of sound card inside the computer is to change analog signal into digital signal. Sound card has capabilities to store and play this speech signal. These are the following building blocks for general speech recognition system. The first one will be signal pre-processing. Second is feature extraction. Third is language model. Fourth is decoder. And fifth is speech recognition. The flow of building blocks for general speech recognition system can be seen in this figure. Firstly, signal pre-processing. Firstly is signal pre-processing. Speech signal captured by microphone and telephone are analog in nature, so it is required to digitize as per Nyquist theorem. This theorem states that a signal is to be sampled more than twice the rate of highest frequency present in it. Generally, sampling frequencies for speech signal are 8 kHz to 20 kHz. Next is feature extraction. Feature extraction is used to find a set of properties that are stable and acoustically correlated to each other. Therefore, it is a type of parameterization of speech signal. The goal of feature extractor is to identify relevant information for purpose of accurate classification. The most widely used feature extraction techniques, which had a drastic revolution and innovation in speech recognition, are linear predictive capsular coefficients, LPCC, mel frequency capsular coefficients, simply MFCC, and perceptual linear prediction, PLP. We'll look further into this. First and foremost, linear predictive coding, LPC. It is one of the best signal analysis techniques to estimate the basic parameters of speech. The basic concept behind this technique is that the present speech samples can be approximated by past samples by following a linear combination. A unique set of feature vectors can be obtained by minimizing the sum of squared differences between actual speech samples and predicted values. Figure shows the steps to extract the feature in LPC. Next is mel frequency capsular coefficients, MFCC. The MFCC features are widely used in speech recognition due to logarithmic positioning of its frequency bands. It approximates the human auditory more as compared to the other techniques. In order to extract the MFCC coefficients, the signal at input pass through the Hamming window to minimize the discontinuities of signal. Then, discrete Fourier transform, or also known as DFT, is used to generate the mel filter bank. The width of triangular pulses varies according to mel frequency warping. Finally, inverse discrete Fourier transform, or also known as IDFT, is used for calculation of capsular coefficient. The figure shows the steps involved in MFCC feature extraction. Perceptual linear prediction, PLP, demonstrated an improvement over the linear predictive coding, LPC, which we saw just now, due to its three principal characteristics derived from the psychoacoustic properties of human hearing, like spectral resolution of critical band, equal loudness curve, and intensity loudness power law. Figure shows block diagram of PLP feature extraction approach. Now, we'll see at language modeling. Language modeling is used to find the correct word sequence by predicting the nth word using n1 preceding words. Language modeling is of various types. Firstly, we have uniform model, where occurrence of each word is equally probable. Secondly, we have stochastic model, where probability of present word depends on probability of word preceding it. Thirdly, we have finite state languages. This language modeling use finite state network to define allowed word sequence. Next, we have context-free grammar, CHG. It is used to encode allowed sequence of words in speech recognition system. CHG follows a mechanism for defining languages such as sets of acceptable sentences. It is powerful as compared to finite state grammars, FSG, due to imposing more structure on sentences. Human languages are actually close to CFG. So CFG is used to model a language in speech recognition by expanding its special non-terminal symbols after applications of production rules. Next, we'll look at decoder. This stage is involved to find most likely word sequence for the given observation sequence. Generally, dynamic programming algorithms are used to solve this problem. The purpose of these algorithms is to search single path through the network to have best match for the given sequence. Vertebi algorithm is mostly used for this purpose. In case of large vocabulary, a beam search method is useful for vertebi iteration. Next is speech recognition. Speech recognition is completed in two phases. First is training phase, second is testing phase. To begin with, training phase is just similar to identification of objects. It may be repeated many times for better recognition, which improves the performance while testing. Second is testing phase, which includes the comparison between the reference pattern scored while training and spoken words at the time of testing. Now, we will look into types of speech recognition. There are 4 types of speech recognition. First and foremost is isolated words. Second is connected words. Third is continuous words. And fourth is spontaneous words. Firstly, isolated words. Isolated word recognizers are generally obtain each utterance to have quiet on both sides of sample window. These systems usually have 2 states, which is first is listen state and second is non-listen state, where speaker has to wait between 2 utterances. The pauses between utterances are used for processing speech signals. Next, we have connected words. In connected words, it is similar to isolated words with only difference of minimal pause in between them. Then we have continuous words. Continuous speech recognition involves almost natural way of speaking. It is difficult to design continuous speech recognizers because it considers special methods to determine utterances boundaries. Then we have spontaneous words. Spontaneous speech covers the mispronounced, unrehearsed non-words with false statements which are difficult to read. An ASR system under this category is to handle a variety of features such as words being run together such as ms and rs. Innovations in speech recognition. Innovations in speech recognition can be observed in methodologies of speech recognition, which are commonly classified into 6 categories, namely acoustic phonetic approach, pattern recognition approach, artificial intelligence approach, generative learning approach, which is known as HMM, GMM, discriminative learning, HMM, ANN, and deep learning, simply HMM, DNN. Now, let's look at the methodologies one by one. Firstly, we have acoustic phonetic approach. Acoustic phonetic approach is a rule-based on approach of speech recognition. According to this approach, there exists a finite distinctive phonetic units in spoken speech utterances. These acoustic properties are present in speech signal. Acoustic phonetic approach involves the spectral analysis of speech signal to extract set of features for segmentation and labeling of speech signal into stable acoustic regions. In this way, a valid word from segmentation to labeling is produced. The following is the figure for the acoustic phonetic approach. Next is pattern recognition approach. This approach is completed in 2 steps. First step is used to train speech recognizers with each possible pattern. The second stage provides a direct comparison between unknown speeches to the pattern learned in training stage. This approach have well-defined mathematical framework which maintain consistent speech pattern to be recognized. The pattern recognition can have any of the form, either a search template or a statistical modeling. The following is the figure for pattern recognition approach. Thirdly, we have artificial intelligence approach. It is a type of hybrid approach that exploits the idea of acoustic phonetic approach and pattern recognition. Usually, pattern matching is based on dynamic time wrapping, DTW, and hidden Markov models. In DTWs, speech recognition works with classes. Each class can be represented by one or more templates. As the number of templates increases, it improves the system modeling. In advanced system, HMM is preferred over DTW due to improved and lower memory requirements. This approach is used to complex tasks, but it is not so efficient when data sets are large. Phonome recognition is basic approach of artificial neural networks. This is done by technique of intelligence, analyzing and visualizing the input speech. The network contains a large number of neurons. Each neurons count for non-linear weight of inputs and then send results to ongoing units. Training sets obtained where this will help to assign values to input and output neurons. Moving on, we have generative learning approach, HMM, GMM. Generative learning approach provides Gaussian Generative learning approach provides Gaussian mixture model, GMM, based on hidden Markov models, HMM, for conventional speech recognition systems. Speech signal is a short-time stationary signal, so it can be represented by HMM. A GMM HMM is parameterized vector with prior probabilities and state transition probability matrix. It is preferred to use HMM to achieve better performances in advanced speech recognition systems. HMM have better control on data sequence length as per variation in word sequence and accent. Then we have discriminative learning, HMM A and N. Generative learning is used to train a generative model. The neural network was used in the form of multi-layer perceptron, MLP, in 1990s. The MLP output provides the conditional probability. The hybrid of MLP HMM can be created by feeding MLP as input to an HMM. In generative HMM, general feature vectors of MLP is used in combination with traditional feature. Discriminative training using neural networks provides a natural and efficient manner to estimate the probabilities of a speech segment. This type of approach have most effectiveness for the small types of speech units like isolated words, phonemes, but hardly used for continuous speech recognition. Last but not least, we have deep learning, HMM, DNN. Deep learning or unsupervised feature learning is new to the area of machine learning. It is the latest technology for speech recognition that has replaced the older one in all sense. It has generally 3 types of deep architectures, generative, discriminative, and hybrid. The first type is used to provide higher order correlation properties of data. The second type is intended to provide discriminative power for pattern classification, characterizing the posterior distributions of class labels. In the third type, our goal is achieved through the composite output of first and second deep architectures. All things considered, now let's take a look at chronology of advancement in speech recognition. Advancement in speech recognition technology was earlier approached by Davis in the year of 1952, where he devised to build a recognizer for isolated digit recognition. In 1956, Olson and Beller tried to detect 10 distinct syllables of a single speaker embodied in 10 monosyllabic words. In 1959, Fry and Dines built a phoneme recognizer to recognize vowels and consonants by analysis of spectrum and pattern matching. Then, Suzuki and Nakata in 1961 developed a hardware for vowel recognition. Sake and Chiba in 1961 proposed the importance of dynamic programming to align a pair of speech. In 1970, pattern-based speech recognition for isolated words were the key focus for the researchers. In 1980s, speech recognition was focused on detection of continuous words. Hybrid approach was used to enhance the performance of recognition by integration of neural networks and hidden Markov model HMM in 1990. Kruti in 2000 developed a real-time speaker-dependent isolated word recognizer. Continuous HMM was used to recognize the isolated word of Hindi language by Gupta in 2006. Al-Khattab in 2010 implemented an Arabic speech system using HTK capable to recognize both isolated and continuous words. R.K. Agarwal and M. Dev in 2011 proposed a Hindi speech recognition using Gaussian mixtures that exhibits maximum accuracy. ZU in 2014 presented the teaching experiment of speech recognition based on HMM that describes HMM speech recognition principle implementation process to realize a speech recognition system. M. Agarwal and T. Raikwar in 2016 discussed the role and importance of speech processing techniques in automatic speech recognition. In latest, K.A. Kazi in 2018 discussed a hybrid technique for speech segregation and classification using a sophisticated deep neural network, DNN. Now, let's take a look at research methodology. In this, we will see introduction to the development of speech recognition and comparison to older speech recognition technology, problem background, problem statement, questions, objectives, and research methodology. Then we have data collection. Secondary data such as studies are analyzed in the form of articles, theses, newspaper clippings, reference books, written reports, and video recordings. We also have analysis and results, where the analysis was performed on secondary data using qualitative and observational techniques on video recording. And lastly, we have conclusion, where the findings of the study and the need to highlight speech recognition development and innovations. Moving on, we have analysis and result. Now, I will be explaining the comparison between the older and modern speech recognition technology. A comparison has been made in a study by a group of researchers who are K.A. Kazi and T. Nawaz recently in 2018. In their research, they have explained meticulously of the older and modern speech recognition, performance evaluation of speech recognition system, and the benefits and challenges related to speech recognition. Firstly, we'll look at the older speech recognition technology. The first official speech recognition technology was Audrey, a system designed by the Bell Laboratories in the 1950s. Audrey, which occupied an entire room, was able to recognize only 9 digits, number 1 to number 9, which was spoken by its developer, but it did so with an impressive 90% accuracy. Its purpose was meant to be helping toll operators to make more phone calls over the wire, but its high cost and inability to recognize a wide array of voices made it impractical. The next real advancement took another 12 years to develop, which was the IBM's shoebox. It was able to recognize and differentiate between 16 words. Up to this point, speech recognition was still laborious. The earliest systems were set up to recognize process bits of sounds, which are phonemes. IBM engineers programmed the machines to use the sound and pitch of each phoneme as a clue to determine what word was being said. And the system would try to match the sound as closely as it could to the pre-programmed tonal information it had. The technology was, at that time, quite advanced for what it was. However, users had to make pauses and speak slowly to ensure the machine would pick up what was being said. In the early 1970s, the Department of Defense began to recognize the value of speech recognition technology. The ability for a computer to process natural human language could prove invaluable in any number of areas in military and national defense. In the late 1970s and 1980s, speech recognition systems started to become so popular that they were making their way into children's toys. In 1978, the Speak and Spell, which was a children's toy using a special chip, was introduced to help children spell out words. The speech chip within would prove to be an important tool for the next phase in speech recognition software. Next, we have some of the figures which shows the older speech recognition technology. Firstly, we have the figure showing Audrey, a system designed by Bell Laboratories in the 1950s. Then we have figure shows IBM's shoebox, and then we have Speak and Spell, which is a children's toy which uses speech recognition software. Moving on, we have modern speech recognition technology. Modern speech recognition technology is being used to replace other more tiring methods of input like typing, texting, and clicking. Modern speech recognition software enables phones, computers, tablets, and other machines to receive, recognize, and understand human utterances. It uses natural language as input to trigger an action, enabling our devices to respond to our spoken commands. The ability to talk to devices have expanded to encompass most of the technology that were used in our daily lives, and its success is built largely on data collection. For instance, in 2010, Google made a game-changing development that brought speech recognition technology to the forefront of innovation, which is the Google Voice Search app. It is aimed to reduce the hassle of typing on the phone tiny keyboard and was the first of its kind to utilize cloud data centers. It was also personalized to our voice and was able to comprehend the speech patterns for higher accuracy. Additionally, one of the modern applications that aim at achieving efficient transcription is automatic speech recognition software. This software is designed in a such way that it understands or recognizes human voice and converts the spoken words into text format in a matter of seconds. Accurate and timely documentation of relevant data proves to be a crucial element in different organizations, especially in industries such as healthcare, where quality of data and data integrity play a much more critical role. Here is the figure which shows the wide usage of modern speech recognition technology and also shows the Google Voice Search app. Now, we'll look at the performance evolution of speech recognition technology. The performance of speech recognition system is generally measured in terms of accuracy and speed. Accuracy of system is considered in the terms of word error rate, which is WER. Therefore, performance defined in word recognition rate, which is WRR, is a complementary part of word error rate, WER. Word errors can be divided into number of insertions, substitutions, and deletions while recognizing a speech. These two performance factors can be evaluated by following equations, in which word error rate, WER, has the formula of I plus S plus D divided by N, where I is the number of insertions, S is the number of substitutions, and D is the number of deletions. And N is the number of inutterance. Word recognition rate, WRR, has the formula of 1 minus WER. For speed, real-time factor is defined or computed by the following equation, which is real-time factor RTF is equals to T divided by D, where T is processing time and D is the duration. There are many advantages of speech recognition technology. To begin with, speech recognition makes everyone accessible to others. As speech recognition technology requires only voice, it is a great option for people with motorical disabilities. There are many people with visual impairments who rely on screen readers and text-to-speech dictation systems, and converting audio into text can be critical communication tool for the hearing impaired. In addition, using voice recognition software can significantly help people with other kind of disabilities like arthritis or hand tremors, which can worsen if typing too much during the day. Moreover, speech recognition enables hands-free technology. When eyes and hands are busy, such as when someone is driving, speech is incredibly useful. Being able to communicate with speech recognition technology like Apple Siri or Google Maps to take a person to their destination reduces their chance of getting lost and removes the need to pull over and navigate a phone or read a map. Furthermore, speech recognition technology reduces spelling errors. Speech-to-text processors relieves individuals from having to pay attention to spelling, which makes them able to dictate directly into the digital device, and it ensures that spelling errors can be reduced considerably. Additionally, speech recognition boosts productivity levels. When talking about workplaces, voice recognition can provide support and assistance with task management duties, such as setting up conference calls, scheduling meetings, or setting up reminders. Such an approach enables companies to streamline the process for everyone, leading to improved productivity and efficiency. With the development of voice recognition, it is now possible to acquire relevant information upon a voice instruction or request data for any specific project, in which all of these activities can now take less time than it would usually do if we did it manually. Moreover, translational capabilities enable people who speak different languages to communicate. The technology has the capability to translate the content into the target language, which helps to remove the language barriers within daily business operations. Now, let's look at the example of usage of speech recognition technology via Google Map for traveling. There are also challenges of speech recognition technology that cannot be denied. The first challenge of speech recognition technology is accents. A wide range of accents in every language is another factor that leads to difficulties in speech recognition. If the same word can be pronounced in a number of different ways, the syllables and phonetics of the same word tend to vary, making it harder for the speech recognition machine to process. Besides, speech recognition have disorganized speech problems. The bringing together of words in daily conversations mean that many words and phrases merge together. This is unsuited to machine and voice-to-text recognition, as it makes it harder to recognize specific words or phrases that will influence the device's consequential response and actions. On top of that, Training is needed in speech recognition technology, where the software or speech recognition needs to be trained to understand and recognize the voice of the dictator, in which transcribing voice data from more than one person is further difficult. Here is one of the challenges of our speech recognition technology, where our training in speech recognition technology is needed. This is the example of process of training in speech recognition technology. Last but not least, we'll look at the conclusion. Taking everything into account, speech is basic mode of communication between human beings, so a feasible interface is required to connect human with machines. Although this field has gained a wide approval to automate the services and applications, there are several parameters which affect the accuracy and efficiency of speech recognition system. The most of speech variability involves speech rate, environmental conditions, channel, and context of utterance. Robustness of speech recognition system depends on some stable parameters and features of speech signal. Enhance the power of speech recognition system, it is required to design speech recognizers in local languages. Multilingual is new evolving field in area of speech recognition, and there is a lot of development and research in this field of foreign languages. But to enhance its power and utility for native people, it is essential to use this technology in native languages. Finally, these are the references which I used to create this presentation. All in all, thank you very much for lending me your ears to listen to my presentation. Thank you very much.